Okay. So, brief revision of this the last class, that is we discussed about the features of binary tree and binary search tree. You know that binary search tree is a special type of binary tree with a special property that all the left nodes will be having the less value than its parent node, and on the all the right child right nodes will be having the greater value or equal value than its parent nodes. This is a special property of the binary search tree. Okay. And we also discussed the different traversal technique, in-order traversal, period traversal, post-order traversal for a binary tree, and how to form
The
a
function
binary
within the
tree
function
with
program
the
single
in-order
language, right?
sequence and pre-order
But here
sequence.
instead of
These
one,
also we have discussed in the last class. Today we are going to discuss very important feature of binary tree, a special type of binary tree. You can say that is an AVL tree, right? AVL tree. The name has come from these three inventors, Adelson, Velsky, and Landis. You can also get a question from anyone on that what do you mean by AVL tree, or how does it stand for AVL? Okay. So you have to keep these names of these inventors in mind: Adelson, Velsky, and Landis. Okay, the AVL. Mainly that whenever we discuss any tree, I started with a concept that is each and every tree has a height, right? Specific height. And we can say that each and every height is assigned with a specific level, right? Like say root of the tree uh, will have the 0 level, then each child node will have the level 1, level 2, level 3, this way. Okay. So, so each and every tree is assigned with a certain height.
let me start
And you can say that
presentation.
the
Got it?
স্যার
heights
একবারে
of the
ডিসপ্লের
left
জায়গাটা দেখাবে
So
may not be
watch
equal
the
to the
video
height of
again,
the
and
right
if
side
you
tree for a
follow the
particular tree,
video, so
isn't it?
just
For
array
example,
or
say
see
you
value
consider
ইয়েস
this tree. If you
function,
consider
value
this
of the
tree, it has a height in the left side. It's a 1, 2, 3, 4, but no right child. So the label height of the right subtree is 0, or height of the left subtree is 1, 2, 3, 4. Okay. So it depends on the structure of the tree. And these numbers, you know that it is the key values, nothing. Okay. And a unique value, or it may be a record. I discussed all this in earlier classes. So here main property of the AVL tree that each and every node will be assigned by a specific factor that is called the balance factor. Balance factor. How we measure this balance factor? Very easy. It is just it comes out from the measurement of the level. For example, this node, for this tree, this node has a balance factor 0. How it comes? Height of the left subtree minus height of the right subtree. You can see the height in the both the sides equals. So left subtree minus right subtree. If we subtract height of the right subtree from height of the left subtree, it will be 0 if these are in the same level, isn't it? Okay. For example, so this tree, second one, all of you look at the diagram carefully. For this, it's a tree. Okay, it has two left nodes. This node will be having a factor 2. How it comes? Height of the left subtree minus height of the right subtree. Height of the left subtree, you can say there are two levels, isn't it? B at the first level, A at the second level. So height of the left subtree is 2, and no nodes in the right subtree. So it is 0. The 2 minus 0 comes 2, isn't it? Got it?
Yes, sir.
Yes.
You are getting now. It's very easy.
Yes, sir.
You concentrate on these digits. And for example, say this digit, how it comes? Height of the left subtree is 1, but no right subtree is there. So 1 minus 0 is 1. It has no childs. So 0. Okay. And like that, this is also a tree. It has only the right childs. 2 levels. Height of the left subtree is 0. So 0 left subtree minus right subtree. 0 minus 2. It must be minus 2. 0 minus 2 comes out minus 2. But here only the value is written. Okay. Here the sign has been discarded. Only the numerical difference we are concentrating. Right. Now you can notice one thing. This digit 2 in every tree, in both the trees, comes with the red color. Isn't it? Hello. Could you notice this one?
Yes, sir.
Red color. Why?
Yes, sir.
Because it is violating the rule of AVL tree. It has no digit with the, it has no factor the red color. It is balanced tree. So you have to understand that what is the balanced tree and what is not balanced tree. A balanced tree is a tree where each and every node must be assigned with a balance factor ranging from -1 to +1. I repeat, a balanced tree is a tree where each and every node of the tree must be assigned with a balance factor ranging from -1 to +1. You can note down this. The definition, you will not get this complete definition as I said. You can note it down, or you can watch the video later. You will note it later. Okay. You just try to understand. Here, range has, means it is not within the 1, 2, 2 is comes with a greater range, right? Means each and every node will have either 0 balance factor, 1 balance factor, or -1 balance factor. These three are these three values, -1, 0, or 1. Any of the values. These three values only are permissible values. Not more than 1 or not less than -1. If we get such a tree where any of the nodes has the value which is greater than +1 or less than -1, will call the tree is not balanced. Got it? Hello? Up to this point you got it?
Yes, sir.
Yes, sir.
Node is having 0. If here up to, if you consider this subtree 1, 0, it is a balanced tree. But when you are considering this tree as a whole or this tree as a whole, since A is having or C is having 2, so it violates the rule of AVL tree. So we will call this tree is not balanced, not balanced, not balanced. So AVL tree is such a tree where each and every node, that tree will be balanced. So if we get this kind of unbalanced tree, our responsible will be to make it balanced, right? You can ask me, sir, this is for -1. You want to see the -1, right? See, if C, consider C has another child, let's say D in the right side, right? When you check the value of A, it will be 0. Value of C, what is the value of C? Balance factor? Balance factor? If we get a right child over here, what is the balance factor of C? 0 minus
0.
1, left sub tree minus right sub tree, isn't it? Hello.
Yes, sir.
And it will have minus 1. What the B will get? B will get left side subtree height is 1 and 2. 1 minus 2 minus 1. So this way you can also get a minus 1. Then also you will call the tree is balanced tree, right? But these two trees are not balanced. So first we have to know how to make an unbalanced tree in balanced, right? How to make it balanced. All these words are written what I said, right? So balance factor is this. This is called the balance factor. Balance factor. Okay. Factor means balance factors. Height of the left subtree minus height of the right subtree. What I just said. Okay. So if the difference in the height of the left and right subtree is more than 1, the tree is balanced using some rotation technique. So if we get such a tree like this, we have to make it balanced. So there are 4 ways, 4 techniques to make an unbalanced tree balanced. What are those 4 techniques? This is very, very important for your exam. From this AVL tree also, you must get a question. If you go through the earlier, means previous year questions, you got so many questions from tree, and this on the theoretical questions. No need to write the code, only theoretical questions. If you study this properly, you can score good, right? You can get a good mark. So AVL, there are 4 kinds of rotational technique, means we call it rotation. With the proper rotation, we can make an unbalanced tree balanced one. So there are 4 kinds of this rotation: left rotation, right rotation, left right rotation, right left rotations. Okay. So one by one we will discuss. You can see this is an unbalanced tree since A is having 2, right? So we have to make it balanced. So if we rotate this tree, this portion, this A in the left side, rotate left, then A will come at the left side of B, isn't it? We are rotating this tree, so A will come here, isn't it?
Yes, sir. Yes,
So
sir.
we are getting the balanced tree. So from this, after left rotating this tree, a part of a tree or subtree, so we are getting a balanced tree. Here you can say that each and every node is assigned with the balanced 0, right? So you can say the balance. So this left rotation, we can make an unbalanced tree a balanced one. Similarly, right rotation, we will rotate at the right side. So this is an unbalanced tree. To make it balanced, we are rotating the right side, right rotation. So through the right rotation, we are getting this kind of tree. So B will come here, A and C will come at the right side of the P. Okay. So this is also an example, just opposite of left side tree, right rotation. And left right rotation. There are 4 steps are there. Left right rotation. You can also say this is a double rotation. First we will rotate left, then we will go for the right rotation. For example, this is an tree. Our node has been inserted here. B, the node B has been inserted into the right subtree of the left subtree. Means right subtree. B has been inserted in the right subtree of A to the left subtree of C. This makes C unbalanced node. These scenarios cause AVL tree to perform left-right rotation. How we will do this one? Step 1. First, we will go for left rotation since it is left-right rotation. So first we have to go for the left rotation. If we rotate the left side, this subtree, if we rotate this one, so A will come here and B will come here. B will get the place of A and A will come in the left side of B, right? So this you are getting this, A will come in the left side of A, and B has got the position of A, right? Isn't it? Left rotation. Are you getting? It's very easy. But still, this tree is not balanced since C is still having the factor 2. So now you have to go for the right rotation. Now you go for the right rotation. If you go for the right rotation of the upper part of the tree, the C will come at the right side of B. C will come outside of B. Then we are making the tree as balanced one. Got it? So with this
Yes, sir.
double rotation, we can make an unbalanced tree as balanced one. This is an example of left-right rotation. You can get a question that with a proper diagram explain left-right rotation. Then you will just write this part, this answer. Okay, you will get the full marks. Got it? Right, left
Yes,
rotation.
sir.
First we will go through the right part, right rotation. Then we will go with the left rotation. So this is an example where we have to perform right left rotation. A node has been inserted into the left subtree of right subtree. This B has been inserted to the left subtree of C, which is at the right subtree of A, right? So we have to make this tree balanced one. So first right left. So first you rotate this subtree the right. So if you rotate this subtree in the right direction, so B will come here, okay, and C will be the right child of B, okay. C will be the right child of B and B will get the place of C. Got it? Still, it is not balanced. So to make it balanced, now right rotation has been done. So left rotation is yet to be done. So now you go for the left rotation. If you go for the left rotation for the upper side of the tree, upper part of the tree, then A will come in the left part of the B. Okay, left side of the B. So this comes with the balance. Okay, got it? Very easy. So this is an important topic, that what do you mean by AVL tree? What is balance factor? How many types are there to make an unbalanced tree in the balanced one, right? So you have to write all this. Got it? Now,
Yes, sir.
most probably, so many of you might have heard this term spanning tree, right? It is a part of the mathematics. Okay. You might have studied graph in your means HS level or 10+2 level, right? Or you will study in engineering mathematics also graph. Graph is nothing but some collection of nodes in a connected manner. All the nodes will be connected. Got it? Here, so far the trees we have studied, the nodes are not connected, isn't it? You can see this open, leaves are open, isn't it? But graph
Yes, sir.
have all the nodes connected. So that is called a graph. And here the nodes sometimes we call the vertices. Okay. So it's a tree, but the nodes are connected. So you can, and when we'll call the graph as a digraph or dated graph, when you know that these are the called paths, and each and every path is assigned is some weight. We can consider these paths as a distance, right? Since the distance between A and B is assigned for this path, distance between C and B is assigned to this path, right? Means in your critical path method, you have studied critical path method, CPM or PERT. Hello.
হ্যাঁ স্যার পড়েছিলাম হ্যাঁ স্যার
It's scheduling with especially for in the mechanical engineering or electrical engineering. I think CPM and PERT is very important. Okay, to get a shortest path. Okay, so we need to uh, study this analysis technique, CPM, PERT, critical path method, program evaluation review technique, all this, right? So directed graph means here the path will have certain direction. Means we can reach from A to C if the direction is in this word towards C, but we cannot go from C to B, C to A. A particular direction will be given, means unidirectional. Okay. And generally the bidirectional, I mean, you can go from A to C or C to A, or you can consider that A can send the signal to C or C can also send the signal to A. Then it is called a bidirectional graph or undirected graph. Okay, means no specific direction is there. Got it? So these are the properties of graph. You will you are having a special means topic on this subject graph. We will study the graph in detail manner in later. Okay. So for this discussion, spanning tree is a special type of graph where we have to uh, we have to uh, construct the graph in such a way that it doesn't form a cycle or closed one. You can say this graph is a closed one. It is forming a cycle, isn't it? তাই তো একটা সাইকেল
হ্যাঁ স্যার
আমি এটা ক্লোজড ওয়ান না এটা স্কোয়ার হতো তাহলেও মনে করো একটা ক্লোজ পেতাম আমি এ বি সি ডি আসতো ক্লোজড হতো তাহলে স্প্যানিং ট্রি ইজ আ স্পেশাল টাইপ অফ ট্রি where from the graph we have to consider that we will be forming a tree so that the nodes will not form a cycle. If you cut this path, we are getting this diagram, isn't it? Got it? From this one.
yes sir
So this is one kind of spanning tree. One spanning tree. We can also form another spanning tree, second one. If we cut this path, C to B, right, the B to C, we can get this one. Or if we cut this one, we can get this one, right? So spanning tree is a special type of tree where the nodes will not form a graph or closed cycle, right? So if you are asked draw the possible spanning trees from these graph, these 3 spanning trees you will write. Okay, and there's an example that how many spanning tree you can generate from a graph. It's a question of gate also, right? The example is 2 to the power n minus 2. N is the number of vertices. So from this, see, n is 3, isn't it? 3 vertices are there. 2 to the power n minus 2 means 3 minus 2. N minus 1. 3 minus 1, 2 to the power n minus 2. Just a minute. 3 minus... no, sorry. N to the power... n to the power n minus 2, not 2 to the power, right? I told wrong. The formula is n to the power n minus 2. So here number of nodes is n. So just put this n 3. Just put the value of n as 3. So 3 to the power 3 minus 2. It comes out. It comes out what? 3 to the power 3 minus 2. 3 minus 2 is 1. So 3. So you can get 3 number of spanning tree from this. Had it been 4 nodes, right? A, B, C, D, a square one. Then how many spanning tree can be generated? 4 to the power 4 minus 2 means 4 square. 16 number of spanning tree will be generated from a graph with 4 number of vertices. Got it? This.
Yes, sir.
I think one example, no. If you this is also you can test it. So suppose you are asked to draw all the spanning trees from A, B, C, D, a square graph, right? So if you will count that whether the spanning number of possible spanning tree you are generating, if it is less than 16, then definitely you will think that you have missed 1 or 2 spanning trees, right? So it is also will be helpful for your verification. Got it? Okay. The general property of spanning tree, you will study all these. A connected graph G can have more than 1 spanning tree. All possible spanning trees of graph G have the same number of edges and vertices. The spanning tree does not have any cycle or loops. You can also call cycle as loop. Removing one edge from the spanning tree will make the graph disconnected. That is, the spanning tree is minimally connected. Okay. Adding one edge to the spanning tree will create a circuit or loop. Means if you add this one, this will form a cycle as it was before, right? This is the property of the general property of the spanning tree you will study. Okay, mathematical properties of spanning tree, just now what I said, the spanning tree has how many edges? N minus 1. See each and every spanning tree. How many edges? If a number of edges is n, so n minus 1, 2 edges are there, 2 edges are there. Okay, so this is also on property, mathematical property of a spanning tree. Spanning tree will have the n minus 1 edges, where n is the number of nodes, right? For a complete graph, by removing maximum e minus n plus 1 edges, we can construct a spanning tree. E is the number of edges, n number of vertices. A complete graph can have maximum n to the power n minus 2 number of spanning trees. Just what I said. Application of spanning tree. It has several applications. 3 major applications mentioned: civil network planning, computer network routing protocol. There are so many routing protocol when we study the computer networks. As I told you earlier also, that computer networks is a special subject in computer science, and I'm not sure whether you are having any such subject in fourth year also. Perhaps you are having also, you also are having a subject computer networks, right? It's also important. So in that subject, you will get to see that there are so many protocols. Protocol is a set of rules to have a smooth communication between one point to another point, from one computer to another computer, from one system to another system, from one node to another node. These are the synonyms of all these nodes, computers, systems. These are all synonyms, right? So for the smooth communication between two computers, we have to study in computer networks different kinds of routing protocol. Generally, we get it in the network level. There are some levels, right? According to the international standard for international organization for standardization worldwide, there are some certain levels. Like say TCP/IP or OSI model, right? So network level is a level where we are having this kind of routing protocol. So the spanning tree also is applied over there. Cluster analysis. Cluster means, have you heard the name cluster? Hello.
No,
Have
sir.
you heard the term cluster? Where? Circuit theory.
Sir.
Cluster is nothing. Cluster is a collection of some items. You can say nodes or some specific items which have the similar property. Got it? Hello. Got it?
Yes,
Means
sir.
it has same specification. There are 100 items in a circuit or in any circuit design, right? Or in a total means project. Let's say the transformers with the same kVA will come in a separate cluster. Okay, a generator or motors with the same specification will have a separate cluster. So cluster is nothing. It's a collection of some items which have the similar properties. So in the cluster analysis, we can have the application of spanning tree, right? Minimum spanning tree will study all this, and I have not checked whether these two algorithms are there. I think these two algorithms are there. These two algorithms are very popular for to find the minimum spanning tree, right? Kruskal's algorithm and Prim's algorithm. Have you heard this term, Kruskal's and Prim's?
No, sir.
Actually, it finds the shortest path. Okay, so minimum spanning tree. So I will check whether your syllabus, if these two algorithms are there in your syllabus or not. If it is there, then I will discuss in another class, right? So it's very important. You can also get a question that give an example of to find minimum spanning tree, right? Or algorithm, name of the algorithm. So we will answer these names. Kruskal's and Prims, both are greedy algorithms. There are different kinds of algorithm according to its nature. So greedy is one specific uh, algorithm which has a specific nature. Okay. Next topic is B tree. It is also very important. Should I stop it here? Should I proceed? B tree will be discussed in the next class, or should I stop it here? B tree also very important. What do you say? Should I stop it?
Next class ago.
হ্যাঁ আমারও আজ আর ভালো লাগছে না তাই তো হ্যালো I
Hi, sir.
proceed. If you ask me to continue, I will continue. What do you say, all of you?
Sir, next class.
নেক্সট ক্লাস ঠিক আছে, তো নেক্সট ক্লাসে থাকবে। তবে আমি মোটামুটি যা যা পড়াচ্ছি, হয়তো বিট্রি আমি থাকতে পারে কিছু শর্ট কোশ্চেন, আমি দেখি নেক্সট ক্লাস পাবো কিছু শর্ট কোশ্চেন, আমি নোটটা দিয়ে দেবো, ঠিক আছে? শর্ট কোশ্চেন থাকতে পারে, আমি ভেবেছিলাম বিট্রিটা কমপ্লিট করে দেবো। তো এনিওয়েজ আমি এটা নোটটা দিয়ে দেবো, তারপরে বিট্রিটা নেক্সট ক্লাস ডিসকাস করবো, ঠিক আছে? ওকে,
Okay, sir.
so
Okay,
we just conclude our today's discussion. If you have any question, you can ask me, or you can post in the classroom also. Okay. If you get any difficulty to understand, then we can discuss on that. So, okay. Bye bye, all of you.
Thank you, sir.
Thank you, sir.
Okay.